Okay, welcome everyone to this week's compiler architecture meeting. Today we have two topics. First is Boris Shingarov, who will be talking about some IL specification topics. And the second topic that we have is one from Devin Pepino about introducing a new IL opcode. So to begin with, we'll start with the IL specification. So Boris, can you take it away?
Yes. So, well, first of all, what I would like to ask this audience is that you guys don't take this too seriously. This is not in any way an attempt at a lecture on how I think it should be done or what should be done. I'm just my goal here is more modest. I'll just describe a couple of experiments that I've been doing in the last more than 6 years now. And the goal that we started with and that motivated us was we wanted to build a VM for Smalltalk that would be somewhat trustworthy. And we tried a couple of different approaches. So one approach, which isn't really what I want to talk about, but for the sake of completeness in description of what we tried, it's described in a paper presented at IWST 2017. We took CompCert compiler and we replaced the last pass. Actually, all the previous passes. No, we kept the machine pass and we replaced everything else just with the normal chain of passes leading to the AL, and the path from the AL to the match specification. We replaced that path and we provided hints for constructing the proof of the correctness of the path in Coq, and that work is incomplete, and it's not that interesting, although it is. We obviously did. We had to provide a spec of what the IL is doing in order to prove equivalence. But that is not what I want to talk about. What I want to talk about is this other approach, which is basically you take a formal CPU spec and from that, both the hardware guys are deriving all the silicon from the spec through whatever they do. So I don't talk about this here. And then what we do is we do an automatic synthesis, taking a spec of the semantics of the IL. We combine it with the formal CPU spec, and that's how the backend, whatever the JIT, the peak of the VM, whatever else is derived from that. And this is actually not something very new. This has been going on for static languages for quite some while. For our LLVMs that we worked with, this has been working pretty well since for the last 5 years. So we showed working proof of concepts. We started with constructing this for an academic small talk that John Sarkle is doing at North Michigan called Mod Talk. And we presented first results in 2014 and then again in 2015. And in 2016, this was complete enough to run the whole ANSI tester. And then in 2018, we tried running some methods, like actual Smalltalk methods, with an actual production Smalltalk, not an academic one, and this kind of proves that the approach is viable. What we take as inspiration here is two systems. One is ArchC/ACC-Gen. It's a research project that has been going on. Well, their paper is from 2012. So they have a custom DSL that formalizes the ISA. RHC formalizes everything that is enough for synthesizing the full bin utils, like assembler, loader, and so on. And ACC-Gen is another is an extension of the RHC DSL that specifies the actual semantics of each instruction. And based on that, they had a solver that they wrote in an ad hoc manner in C++. So they take those RTL-like semantics and they synthesize the bin utils and they synthesize a complete LLVM backend from those stacks. And I can show you what that looks like if somebody is interested, because we have all this. Another point from which we started is the anger system. What those people do is they try to do analysis of random or arbitrary executables to see attack vectors. These people, they are security. They're interested in security things. So they are interested in things like proving absence of buffer overflows to take control over the machine and stuff like that. So what they do is they look at the binary and they use Valgrind to parse that the binary text and lift those CPU instructions to an IR they call VEX. And that IR has simple enough semantics that they can execute that IR algebraically, or they call symbolically, but there's a couple of different meanings. That's some ambiguity when you say symbolic. So what they do is that they're not just symbolic instructions. What happens, like operations for add or a multiply is not just a name, but they actually do computer algebra with it. So if you say, well, in register R1 or EAX, there is some value, and that value is X, and you do an increment, when you execute that instruction, they can reason and say, oh, well, now the value is x plus 1 under certain conditions. And it is more systematic than ACC gens. They reuse the existing Z3 solver from Microsoft, and they wrap that in Python. They also wrap in Python parts of Valgrind and they reuse a bunch of interesting things. And all of the rest is essentially integrative and written in Python. So reusing all that, they are able to symbolically execute binaries for mini ISAs. People have been reusing that for construct super optimizers for that. And what's interesting is because it's all algebraic and symbolic, what happens is that, well, essentially, you don't really just throw random stuff at the super optimizer and see, it's not really a random search. It's really logical synthesis or logic derivation from what Valgrind gives you looking at the CPU instructions and that it derives real logic from them. So we took this and well, my stuff is based on those two pieces of work, and we are able to synthesize a backend for a VM from given an operational semantics for NIL and a spec in Archie's DDL, their processor description language, which is a DSL. So we parse that. While parsing, we assert each of those facts as a fact into a Prolog database, and then there is a solver, which is Prolog, but it's not just pure Prolog because when you try to unify for each bytecode, there is going to be a fragment 3. So it's just a term with some subterms, and you try to unify that tree or that term with what is available in each as a semantic of each instruction. And if you try to do that, you're going to get so much backtracking that essentially it's going to be computationally intractable. So what you need is some sort of constraint propagation system, and what I use is the COPZ for solving. So it's not just going to backtrack. I mean, it does backtrack a lot, but it prunes the unnecessary branches very early. And then for rewriting, I use the Van Emden equational rewriter. And what this looks like, well, actually, this is the actual code that implements. So it has given a rewrite axiom here. So from X rewrites to Y, and then you try to satisfy E. So you give X, which is the IL, and you're trying to satisfy these three equations, and Y is going to be the actual instruction. So you're trying to get E2, and E2 is either itself, so E2XX here is when you are stuck, so you are already in normal form, cannot continue, or you're trying to do a step. If there is a step, so this is essentially a transformational closure, right? So you have E1, which is one step, and if X rewrites to Y explicitly, and you rewrite an elementary effect to an instruction. So if there is for example, if there is an instruction that does what you want, so you've got E1, and then Y rewrites to Z to E2. So you stop because you are already at normal form. And then if there is no instruction that does what you want in one instruction, then you basically substitute a bigger one from two smaller ones. So and you do it on the left, and you can do it on the right. So that's how you get a bigger effect from smaller fragments. And then obviously, well, a bunch of this, and it's not an unconditional. I mean, it as a rewriter, it is a production system, but each production is conditioned by some success conditions. So, for example, on a risk ISA, on any kind of risk ISA, let's say you want to load a 32-bit integer into a register. Well, you don't have instructions that load a whole 32 bits, so you have to synthesize that. But if your integer is small enough and fits into load immediate instruction, then your condition will be something like, well, the integer rate is less than the maximum. So then you conditionally rewrite that effect to this load instruction. If not, then you get stuck on this one, but you don't get stuck because you have the substitutions, and then it will continue to it will continue to try to satisfy the E1 from this one. So, and it works reasonably well. One interesting moment here is that there is the symbols, right, for the operations like plus, right, or bit and or bit or. So you're trying to, let's say you're trying to synthesize that load. So at one point you're gonna have a shift left, and you're gonna have a bit or, right? So how do you know that the whole 32-bit integer can be synthesized by shifting the higher part and then bit oring it with the lower part, let's say, powers. So these things, the shift and the plus, they are treated by this well, both by the prolog system and by the solvers in the CLPZ, and by the Van Emden algorithm. They're fully treated just as simply names, and then you specify a few lines that say, yeah, well, an integer consists of its parts, so you can break it down into integers. And by making this operation, let's say, bit or, you will get the actual bit or of the real, what arithmetic is, or the actual bit or operation, like let me know what it is, right? So it gives you maximum freedom, but when the arithmetic becomes somewhat complex, it is getting more and more difficult to express using this framework. So if you have instructions such as this rotate on PowerPC, you cannot really express it as those counter things. So on Valgrind, the vex file gives you something like this. So you have, like, if you get, so this one is, this is actually how we extract the actual arithmetic value out of a small integer, of a tag small integer. So we shift it and we mark. So you see this T0, which is the actual value of GPR1 of what it is reused several times, so you cannot really construct an actual that will arithmetically this you have to do something. So the reality of what happens is that you don't really use this concept of instructions. So when you are trying to give semantics of what the arithmetic effect should be, you cannot really express something like this. So in the future, the idea is combining Prolog and CLPZ with this more complex, like actual computer algebra, like what the Anger guys are doing. Right. So what did we learn from this? So the approach works. You can construct a VM that will actually execute something as complex as the ANSI tester, but you need a much simpler IL, or I would like a much simpler IL, because we had to just omit certain things in the implementation. It's kind of, we kind of cheated, because ANSI tester doesn't really mandate things like become in Smalltalk, right? So we just drop that and we just silently don't do anything or don't say anything. But we absolutely need something much lower level than actual bytecodes of, be it Smalltalk or Java or whatever. So for the next stage of this, a good candidate, what we're considering is to use TR's IL as the IL for this kind of formalization and automated synthesis of the backend from it. Yeah, I think we can start discussion. I don't know what kind of interest this you guys in the audience, what is your interest? Do you want to see some of examples? Do you want to see some of this actual code? Do we want to discuss what we're gonna do next? Or just do some Q&A.
So I guess thanks for the introductory material. I don't know if there's anybody that's got any questions on that. I mean, I thought that what we could maybe do is talk a little bit about your maybe some next steps, unless someone has any questions or any other things you want to ask. Yeah, I mean, yeah. So, have you spent a lot of time studying the IL that we use in the compiler? And if you determine that it meets all your criteria, or are there things that you might need to change in the IL in order to make that happen?
Well, the extent of the study of the IL was dictated by the work that we were doing for the RISC-V port, right? Yep. Obviously, you cannot make a port of the actual compiler unless you understand what it is you are translating from, right? So yeah, I think we do understand what the IL looks like. Now, to just give an operational semantics of the IL in terms of one system of implementing it automatically on top of any processor, it kind of does formalize the semantics, because obviously, well, it's a machine-readable form from which the synthesizer decides what instruction does what. But I'm afraid that for the needs of the community, that would not be enough. So I think the next step would be to discuss in what form the formalization of the IL itself needs to happen such that it would be consumable, from by all the different parties.
Okay. So when you're talking about if you're talking about formalizing the Testarossa IL now, what would you require for that to happen? For example, you need each of the so it is a tree-based IL. So we would need all the operations to be very clearly defined, and the semantics of all the opcodes to be fairly clearly defined, and the way that the trees can be linked together and ordering and that sort of thing should all be well defined.
Right. And it has to be defined in such a way as to be able to be consumed by so that I can feed it to my synthesizer. But we could also, I guess, people who are working on the Testarossa IL, they have their own plans on why they want this kind of formalization, so they have their own uses for it, right? And when we say formalization, obviously we're talking about machine readable formal specs. So what is the plan? Are you planning to feed it to some sort of machinery that will, I don't know, automatically verify correctness, or like?
So at the moment, the Testarossa IL is sort of an internal representation for the compiler. So there isn't really an external a way of exporting that. The one area where we do that is with this sort of we're getting into more testing. We've been getting into more testing over the past year and a half or so, and one of the things that we had to do for that was to actually export the IL into some format where we could consume it again or make modifications to it so that we could feed it back into the compiler to test certain combinations of trees and that. So that's really the only sort of external external representation that we've ever had. I guess we'd have to think about how we would want to do it if it was required to export, or certainly hear any thoughts that you have on how that should be done, what you think.
Right. Well, when we say formal, right, that kind of presumes that there is some sort of formal either proof checker or something that this formal spec is consumable by somebody, right? So
yeah, the tree validation that happens right now is all internal to the compiler. It's not really externalized yet. I mean, I guess that is something that could potentially be externalized to operate on the whatever external form we come up with. But I guess the challenge that we have at the moment is that a lot of the way that the Testarossa IL behaves is like there isn't any sort of written spec that we follow other than what the code is. That's not necessarily a great answer, but that is sort of how it is. I think that we would and we do want to put some effort into actually having a much tighter specification of the intermediate representation, so that projects like yours can make use of it, and that we can improve our validation story, and to make it easier for other projects that want to consume it to understand what it really means. So we have to put effort into that, and unfortunately we're not too far along that trajectory just yet.
I see. So we're not really even talking about, what we're talking about is just spec, right? Not formal spec in the sense that something, that you feed into a theorem prover. It's, I guess, just for to having an explanation of what each instruction does, right? Or some kind of written down, more or less, exactly what should happen after.
Yeah, I mean, and certainly one might feed into the other, but yeah, we don't really have a lot of even the early groundwork to provide a formal specification, other than the fact that, well, other than the code. So
I'm not even sure we could have a formal specification right now, just because I'm not convinced that every code generator does the same things for each IL. I mean, I know obviously we'd like that to be the case because the optimizer kind of relies on the IL being the currency that of what you're describing, but I'm not sure it's 100% the case in all scenarios that a given piece of IL will translate identically
shifts, for example,
across platforms.
Right.
Yeah, I mean, there's still a bunch of places where the optimizer does have some platform-specific code in it.
Yeah.
Around differences in what the code generators do. I'm not
Yeah,
sure.
well, I think even,
but it's kind of where we are.
Go ahead, Andrew.
I see.
yeah, well, I was just going to say that I think even even with differences, even if the differences in the implementations between some of the code gens were eliminated, I don't think that as a community we really have a good handle on the more corner case behaviors for a lot of the mathematical operations and those kind of things, right? Like how does overflow behave? What are the floating point semantics, which we've already had several discussions on. So there's certainly quite a lot of vagueness in those areas, even beyond the actual code gen implementations, which for the kind of thing that's being discussed would certainly be a prerequisite to be able to enumerate that properly. And I'm not even sure how we would do that. I don't feel particularly qualified myself to try and do that.
Yeah, I don't. So given that and the other things that we've said, I'm not sure if that changes your opinion of the utility of TR IL for your purpose. I mean, you're right that it is a simple IL in some regards, but in some cases, it isn't as well specified as we would hope and as maybe you would like.
Yeah, well, it's no better than any other IL for any dynamic language that we have tried. So it's definitely much simpler than any bytecode set for any real language. So I guess trying maybe one path of attack is try to do something similar from what we already did with what was it? Yeah, this approach, for example, and see where ambiguities pop up, and try to see. Let's say synthesize a backend from a formal spec of semantics of some of these instructions, and then see how they are going to differ from what the existing translator, what the existing generators generate in OMR, right? So, well, actually, it's not even. Oh, yeah, it's not even necessary. It's not even necessary to generate any code for machines, because if you have a semantics and then you say, oh, okay, well, now I'm executing this bytecode and this whatever virtual register T1 contains the integer X. What are register going to contain after the execution of this bytecode? And then you take something like what these guys have, right? This anger, and they say, well, okay, here is the code produced by the existing code generator in OMR, and the value is X plus 1, right? I am grossly oversimplifying. And let's say from the spec that we came up with, it's is it X plus 1 or is it something else, right? Now, yes, this is a very oversimplified view of things, because obviously there are optimizers, and at each step when you do a transformation, the transformation may not actually preserve things. Yeah, but at least we could run some experiments comparing at each step, what happens with that value X. Is it like on an inc? Is it still X plus 1? What's happening? So it's I mean, it's not the value in these verifiers and these provers is not just that you have, oh, okay, well, the final answer is that, yeah, it conforms to the spec, right? It's an actual tool that can analyze all of these edge cases for you, right? It can say, oh, okay, well, it can go this way, it can go this way, it can go this way, and just see where this leads. Well, the reason why I initially proposed that we have this meeting is that we just don't step on each other's toes, and if as I thought, let's say there would be a lot of work already happening on this in the OMR team, that we're not duplicating effort. But from what I'm hearing is, well, pretty much any effort is going to lead somewhere, and there isn't going to be wasted effort.
No, I don't think there's any overlap in what you're interested in studying and the sort of the direction that we're taking the compiler technology, or how we want to document how the IL works internally. So I think that there won't be any there shouldn't be any conflicts there, that's for sure.
Well, if anything, if he's working on very formal specification of specific opcodes, and we're busy trying to get sort of use documentation of how the compiler expects them to behave, I mean, the interaction of those two efforts may help to refine some of the corner cases and identify things we may not necessarily think of, since we don't come from that formal verification, formal semantics background.
Yeah, that's probably true. I think that if there are sort of some milestones along the way with the work that you're doing, we certainly would like to compare notes every so often and sort of see how each effort is progressing, so that one could learn from the other, perhaps.
Yep.
Cool.
Thanks for the talk, Boris.
Okay.
Any more discussion on this topic? Anyone wants? No? Okay. Thanks, Boris. Okay. So next on the agenda, we have a new IL opcode proposal from Devin. So I'm going to turn it over to. Are you going to project it? Or?
No.
Okay. Let me just take. I'll take the screen back from you, Boris. Okay. I'll go back to here. Okay. Go ahead, Devin.
Okay. So if you want to see more detail, the issue that I've opened for this is linked from the meeting agenda. So the idea here is that it would be handy to have a new opcode that both allocates and initializes as one step immutable objects. And the reason for this is that if we separate the steps of allocation and initialization, which we would have to do at the moment, unless we represent ourselves an additional operation in some way, we're going to have stores into the immutable object, and then we're going to have this immutable object where we have to care about where the stores into it are, and it's sort of defeating the ease with which we would like to be able to optimize with respect to the contents of immutable objects. So I've put here as the name new value. It's been suggested to me that people might not like the name, and that's fine. But we'll set that aside. for the moment, and I'm not going to go through all of this in excruciating detail. I think I'm going to give a sort of high level, like the highlights, and then maybe we can talk about it from there. So, what are the good things that can happen during optimization if we have this operation? If we have a new value node and we want to load a field from it, we can just pick the appropriate child, that's it, all the time. There are no stores to that field anywhere. Because there are no stores to these fields anywhere, existing optimizations that care whether they find stores, they will not find any of those stores, and we won't step on them in ways that interfere when we needn't interfere with them.
Sorry, on that point, so what is that child? If you pick up the right child for a particular field, is that the right-hand side of the store that may have been there if we had chosen to expose it as a store?
Yes. And also, because we have a complete set of data to fill this object with before we've allocated it, and we're going to fill it with this data immediately, we never need to do zero initialization or default initialization for the allocation. Additionally, there's this idea, so this is motivated by upcoming value types for Java, in which there is not supposed to be a notion of whether you have the same object. And that may be a concept that applies in other contexts as well. Some language may have immutable values that you can construct with no way of telling, is this the same memory location? I'd like to be able to express, for a given one of these new value nodes, is this something where we don't care what its identity is? If we don't care what its identity is, then that opens up different kinds of transformations that are possible. We can rematerialize it somewhere else by just taking the values that were inside, and we're going to box it over here because we think it's going to be better if we box it over here and we don't have an object over here. Okay, so we can implement immutable objects using explicit initialization as an alternative. That would just mean that we don't get these benefits for optimization. Right? We could represent this operation as an intrinsic call, which is like a call with a special symref on it. That would possibly cause certain optimizations to get conservative if they see a call or something like that. Or OMR could say, well, OMR doesn't care about this, and if OpenJ9 wants to have immutable objects, OpenJ9 figure it out. So, okay. So this opcode, it's got a variable number of children, and they are different types, so it's similar to a call. There's a symref on it that says, here's the type that we're allocating, and depending on what that type is, it has some fields that we will have to know about, and I'll talk about that. Based on that set of fields, there is a fixed sequence or correspondence between the fields and the child indices, one child per field. And that's what it does. So because it does an allocation, it is a GC point. It'll be an exception point, at least in Java it will be, where allocation failure is an exception. Other than that, it doesn't have any, there's no side effects. Now, it will initialize the new memory, but semantically there's no side effect on anything that anybody, like there's no change that somebody could observe. There's no particular constraints on the children. Now, I've got here as a sort of alternative, rather than having the SIMREF on the new value node directly to say what type it is, we could have a different SIMREF there that says whatever, it's JIT new object or something similar to that. You could have a first child that says, here's how we're going to specify the type. That's the way that I originally thought of this. The main thing that would let you do is allow the type to vary, but it's not probably very meaningful to allow the type to vary. So that's why I've decided that that's the alternative, and the main one that I would like to talk about is with the SIMREF directly on the new value node.
Is there an equivalent of, like, so right now with the existing new opcodes, like new array, new object,
yes,
if a backend chooses or doesn't want to or cannot support one of those, there's a sort of a fallback mechanism back to the VM. Is there an
so backend? This won't require support in any particular backend. So we'll get there.
Okay.
So are you saying the aliasing on the SIMREF associated with this will be null? Is that what you're saying?
So, well, there's the GC point SIMREF aliasing, which is an unfortunate thing as far as I'm concerned, but it would have to have that. Okay, that's not a good. Yeah, so that may constrain us in which SIMREF has to go where. But in terms of this reads memory or this writes memory, it does not. I mean, it writes what it's initializing, but semantically it does not write memory. There's a single step where just out of nowhere pops this object that it already has all the values in it.
So if I had a load of one of the fields in this object, it would be relying on the underlying pointer value, store or write to prevent movement, code motion of this load, right? Otherwise, I'm in a loop. I see a new value. Mm-hmm. I see a load of a field out of the new value. Just pull it out of the loop if there's no aliasing stopping me from doing it, right? But it's that base that someone will have to write to the base.
So if you see a load of a field with a new value, you can always eliminate the load. So if you
not
have
literally from a new, if I see a store with a new value under it,
yep,
a store X, let's say,
mm-hmm,
and then some other block in the loop, a load X, and then on top of that, an indirect load to get a field out of that new value, a field out of that new value.
Okay, right. So what would happen in this case is, so the store was outside the loop? Like the object reference is loop invariant?
No, but the new value is inside the loop. The load is also inside the loop downstream of where the new value was done. The new value was stored to some temporary X. Right? You did X field.
Right. So in that case, we wouldn't take it out of a loop because the object reference is not loop invariant. Okay,
so that's what you're relying on here.
Well, I mean, you need to rely on that for any access to a field of an object. You need to know that you're accessing the same object.
That leads to the next question. Is news aliasing or...
So that's not based on aliasing. So like, okay.
So
it's not based on aliasing of a SIMREF, right?
Yeah, I get it. The base will change in that example, and therefore you won't pull it out. So that's how that's supposed to work. You're not going to put any aliasing on the new value.
Right.
Because that's not needed to prevent that.
Right.
But is that a similar approach to what a new would follow, or a new array would follow, or a new array would follow? Or is there some fundamental difference here? And there is.
So what do you mean the approach that the new or the new array would follow?
What's the aliasing of the new?
So I believe that is just, assuming it's a resolved new. Well, actually, I don't think it affects new itself. It affects the load adder. That's where the unresolved bit comes in, and then.
Yeah.
But for the new, I believe it's just that we do, it's just the GC point aliasing.
And that would be what we do here as well, or no, we would not even do that?
Well, we would need the GC point aliasing because it is a GC point.
Okay. I was just trying to make sure that if someone has, so this thing will return true to is new, right? That case.
So that is up for discussion.
Okay.
Because I don't know yet what things, how many places in the compiler we ask is new and then expect the node to look a certain way, and that it might not look exactly the way it expects it to look. And so we could deal with that by saying, refusing to say this is a new, or we could deal with it by finding those places and changing them, and the balance is up to, you know, how much work it is probably. Okay, so does that address your question?
Yeah, I'm just worried that if you say this is a new, from an aliasing perspective, it looks like there's no difference between a new and this thing. There's VC points.
Right. So, but the aliasing on the SIMREF does not express that at all. That's completely separate from anything that the compiler considers to be aliasing, which is weird because it's exactly what aliasing is. So I understand your. But it like when we see that, oh, this is a new, we do not rely on aliasing information to tell us that it's different from another reference.
I'm worried, yes.
Like we don't compute an alias set.
Aliasing is maybe not the right example given this discussion, but what I am worried about is if this thing returns true to is new, and then you have to make an exception for it in some way in some piece of code, right? Like that would be.
So it's going to effectively be a new.
Okay.
The only reason there would need to be an exception is because the code inspecting it might not expect the shape of the tree.
There's a very limited number of places where we call is new, so it should be easy to inspect and perhaps repair all of those places, like extremely limited places.
All right, so.
Okay, and you would have to change all kinds of objects that today know which things define SIMREFs. And so for example, if I had a new value with a right-hand side of what would go into a field under it, and then I had a load of a field out of that new value later in the same block, would local CSC propagate that to?
I wouldn't think that we want to do that in local CSE. We would do that by seeing, we would end up with a load, and the child of the load would be, we're loading from this object, the object is a result of new value.
Okay.
And because we're loading from new value, we can just pick up the appropriate child and we're done. So simplifier can do that transformation. CSE would, like, if it got it through a variable, then CSE would propagate the variable.
Okay.
I just had one question. This is intended to complement the new that we have? Is it intended to replace what we have?
To complement, because it can't replace the existing new. This can only apply to objects where we're constructing an object that's an instance of a type that is always immutable. If there's if we could pass this to a function and it could be mutated, like, we lose all the benefits. So it only applies to immutable objects where we know based on the type that it has to be an immutable object.
Does it make sense to have instead a concept of immutable rather than introducing a new opcode which represents immutable objects?
Well, then we would end up with new is, if you wanted to say, like, okay, well, we have immutable new, well, then now we have two forms of new, where new is sometimes this operation. that does the allocation and the initialization.
Even if we introduce the notion of an immutable, we would still need some sort of new value like opcode just to represent the allocation and initialization being fused together.
And the point of fusing them together is that there is no right anywhere that you can find that messes up any optimization.
Is there an example where this applies today, like in a language? What does an immutable object look like?
So say in a functional language like Objective Camel, you're going to construct a con cell.
Yeah, something a little more
relatable.
Yeah.
Net value type.
Net value type.
Yeah, so this is targeting value types for Java, but they're not in Java yet. So
this is like a struct with const fields that are
right. So you create this thing. There are values that go into it at point of creation, and those values never ever change for the rest of time.
So what if those values come from a constructor, something that behaves like a constructor, and it has arbitrary complexity?
Okay.
And then you have to replace that, or you have to represent that with a new value and children. So what happens if...
Okay, so the way that you construct immutable values in settings where immutable values are a thing that you can construct is that you have everything that goes into it, and you say, okay, put all this stuff together, that's my immutable value now. So this is just representing that step explicitly by saying we have this as a one-step thing so that we don't have to contend with, well, we have these stores somewhere, and then we have to do these analyses to deal with the stores to the thing that's supposed to be immutable.
So this would, basically the initialization would have to be visible at compile time. You'd have to know that everything that's going in there it's not,
like
it's not going to be arbitrarily complicated. It's not going to have side effects. It's not going to be the equivalent of a constructor running.
So like you can determine the values that are feeding into this any way you want. And then once you've determined them, you can do this operation. I'm not sure what the question is.
Well, let's say you had a field. Let's say you were initializing a sequence of fields and...
Like, okay, so the children are not going to have any control effects or side effects or whatever. Like it's a regular IL opcode.
Why wouldn't it, though? Let's say you're initializing it with the result of calling some function that does who knows what.
Right, so you call the function, and then...
Okay, and then what happens if...
And then you do new value after the function has completed. Like it's just the same as if anything else you do with the result of a function.
What if the side effect... What if, let's say you had two fields that were initialized this way.
So you're asking what happens if, like, the side effect happens in the middle of the...
Okay, so like the source code looks...
That's the point.
Right, like the source code looks like this. Compute value for field A. Compute value for field B. Make my thing with field A and field B values.
Yeah.
Think of it like you did a new followed by a constructor call where all the arguments to the constructor call are what's going to be stored to the fields.
That's exactly what I'm imagining,
but there's nothing in between, right? Everything that you needed to compute to pass in was computed first.
Arbitrarily complicated. We don't have to. We don't have to.
All those side effects happen before the construction of the value.
Yeah.
Right.
They happen before
the key point here you did.
Values have all been computed before you...
I mean, the side effects of a constructor happen after the thing is allocated.
Okay, so like a constructor is a particular language-specific construct that, like,
I think the point
because constructor does not mean one fixed thing for all languages.
Yeah. So the idea of your idea of a constructor has to be changed to something where the constructor runs before you've done the allocation, and the constructor, all it does is compute whatever values you're going to put into your object, but the actual allocation of the object happens effectively atomically.
Right. The key point is that you're never going to have code running when the object has been created, but its values haven't been set. And so how the language exposes the semantics of that may vary, but this is a separate concept from new in that with new, the memory is allocated, but the values have not been written, and you can write them at arbitrary time after the creation, whereas this is saying they're intrinsically tied together, and if you want arbitrarily complicated control flow to compute a value, that's fine, but you have to do that ahead of the new value, which is then going to consume as a child the value that's actually going to go in, because intrinsically it's an atomic operation of putting those values into a chunk of memory.
So the way you want to think of it is that in order for like the source code to use this feature, the source code does not say make this thing and then compute some values and then put the values in the thing. The source code says compute some values and then make this thing with the values that I've already computed.
Yeah. Right. It's a byproduct of the bytecode design that causes the allocation to happen in the middle and then the constructor to get called. But if you look at the Java code, right, you just do a new X, pass a bunch of things which are going to get evaluated before you run the new.
Yeah, but those things don't end up, they just end up being passed to a constructor which can do anything it wants with them.
Okay, so let's not think about the regular kind of constructor in Java because it does not apply to these objects.
Yes, right.
The only constructor out here.
We're not going to use regular Java constructors for these objects.
Think of it
The
like
current kind of
Static
constructor.
initialization is a better
it's
kind of.
closer to the initializer list
initializing it.
plus, right? Where you just list the fields and you provide a value for each one, and they.
Well, although even in the initializer list, you can say throw an exception while you're in the middle of it, or.
Okay, more akin to.
It's closer.
Try not to be a phonetic person.
I'm trying to envision how this is, better for me to ask questions now than
Sure.
not.
So if you think of it, it's weird because like the functional programming language example is 100% perfect.
Yes.
If you're familiar with it, it's tough.
I can wrap my head around it. I think I can follow where you're going.
Okay. Okay. Okay, what have we got here? I talked about symbol reference. Now, because of the GC aliasing, we may have to go with the case where it's an extra child that specifies the type. That being the case, we may want to say that that child has to be a load-adder and it has to be constant because we have to know what we're talking about.
That might help you with the is new problem too, actually.
Yes.
One of the structural requirements that will be implied by.
And I had a note up here. Perhaps the first child, perhaps using the first child for this would help a new value to look like new.
I assume the symbol that'll actually be there, like the class, will actually be recognizable as an immutable class itself. Like you'll be able to tell from the class that's being allocated it's an immutable type.
Yeah, well, we will be able to tell from the class.
And you won't be able to do a new of an arbitrary thing, a new value of an arbitrary thing, and have it be filled in as immutable, I assume.
Right. So, I guess what I would say is that it's sort of up to whoever's generating IL to decide whether to use new value. So generally, it should be the case that if we have a type, we can introspect on the type and know whether this is how we want to do the allocation and the initialization or not. I don't think we would want any transformations in the compiler that turn things that we're not already using new value and say, okay, well, now this is going to become a new value. I don't think that makes sense because those are going to be things into which we were storing, and then
we would do that. I was more thinking, could you have a new and a new value that have the same class in that first?
So I don't think we have to prevent ourselves from being able to represent that, but I think that you shouldn't generate that ever. but that being a thing that you should, okay, it being a thing that you shouldn't generate doesn't mean that we have to make it impossible to represent.
Yes, okay.
Because that may be involved. Now, maybe we can expose a query where the compiler can ask, is this one appropriate for use with new value or not, and we can assert on it or something, or put that into the IL validation, which, but we don't need to have like, okay, here's an immutable class opaque class block and a regular opaque class block, and you just literally cannot, you know what I mean?
Is there an equivalent thing for arrays as well that could be created? Is there a new array value potentially needed?
I guess that's possible.
Of course,
I don't think
new value as well, right? There doesn't seem to be any conflict with that. Like you could have an immutable value being used to initialize a value inside an immutable value.
Yeah, so these things are their object references, right? So you can construct one that refers to another. In the future with the Java value types, we're going to want to be able to flatten those things. And that's going to mean that basically the fields of the nested type are promoted to, you know, a field path within the new value, and they would each get their own entry in new value, and then you would load the values out of the. Okay, IL opcode properties. So this should have basically all the same properties that new has.
Sorry, did we answer the array question?
Oh, sorry, back to the arrays. So that could be a sensible operation to have. I don't know. It seems like if you want immutable arrays, there's a distinct possibility that they could get very large.
Yeah,
you don't necessarily want to be generating code where you fuse together that and you end up with a child per array element for many thousands of array elements. And like semantically, that's sort of like we would evaluate all the children and put them in the stack, and then we would allocate the array, and then we would. So it doesn't seem like something that we would probably want for arrays.
And that's not something that is being considered in Java as a language extension of this type, right?
Right.
So, for example, something like an immutable string wouldn't have an immutable data array inside it.
Right. That data array is just immutable by convention and by enforcing an abstraction boundary, and every same as it is now.
One other question, sorry to keep interrupting, but we could stack allocate these as you mentioned, desirable. So in certain...
Yeah. So the idea is that we're going to want to discontiguously stack allocate them basically anytime we can tell what the type is. Because they don't have identity, and this is why, so we want this like identityless or similar node flag. I'd like to represent that explicitly because I don't think it should be a requirement, or I think this new value is useful even if you do have identity. I don't want to say like, okay, well, you know, when we're in OpenJ9, we're just going to know that it's identityless. Like that doesn't seem like a good way to represent that. I would like to have something explicit that says we don't care about the identity of this thing. But all the ones that we generate for value types in OpenJ9 will be identityless in that way, which means if we have a variable x and we're putting a point into x, and everywhere we see x, we're putting a point into it, we can just completely eliminate x and replace it with x, x, and xy.
So does that mean that you will never contiguously stack allocate one of these steps? because if you can contiguously stack allocate quantities, I'm interested in how you would represent that, because you don't have a load adder
Right.
value.
So
whatever you
I
want.
don't expect there would be much motivation to try to contiguously stack allocate one of these.
Okay.
Because of the freedom that's available to blow them apart, basically as much as we want. So. Also, we can box them at any point. So if it's like, it doesn't matter whether it escapes. If it goes off to this cold call and we need a value there, we can allocate it right there with the values of the fields that, right? And the thing too is that it's not like the current heapification where in escape analysis where you have to say, well, we have a pointer and we don't know whether we've moved it to the heap or not. You can allocate it right there and then throw it away. Forget it. Keep on using your local variables because nobody can affect anything.
One of the common places where contiguous allocation happens is if there's more than one path, right? So you have one class that does this kind of new value assignment to T, let's say, another path that stores something else into T, then you do a merge, and you go and say, is T an instance of something, or some use T as an object? You can't blow apart the object in that case. You need to keep it whole in a conventional sense when you're dealing with a new. Could that happen here? Yeah,
so there may be cases, they are object references, so you can have a merge where we lose the type information.
And never mind losing it, you may not even know that.
Yes.
On
exactly.
the other path.
Yeah. So,
in which case it is being used as an object in some places, but on the hot path, not on the cold path.
Right.
And so one would be motivated to put it on the stack just to avoid the heap churn.
Right. I guess it would depend on the frequency of such a situation. I imagine that a lot of the uses of these things are going to be, typed.
Yeah, the instance of is just one example. Although I realize that these are special kinds of objects. Like another one is just I synchronize on it. Right? But probably you don't want to.
What happens with synchronization is going to have to be a thing, and it hasn't even been determined, as far as I'm aware, what's exactly going to happen with synchronization.
Okay, but passing out to a call, for example, have a merge, pass it out as an argument to another call. That's not a type check. That's not a synchronization. It is a use that requires you to have an object, though, of some sort.
Right. So if you've got a variable where I guess this is at least partly tangential because I'm not trying to propose a method of doing the scalarization at the moment. But
right.
It would be...
Sorry, but, okay. You're not proposing a method.
Yes, but I see that it relates to how would you represent a stack allocation that was contiguous if you had to do one. And, I mean, strictly speaking, we don't ever have to do one.
You don't have
to
do one.
So it depends on the balance of...
right, but you may have to do one, and if you did one today without another
we don't have to do a stack allocation.
You don't have to. I'm saying for performance reasons, let's say we said we need to do this.
Yes, it may be desirable in some case. I agree.
And if you did that, the only way you could do that today would be a load adder with the stores explicitly coming after that, right? Unless we came up with a new proposal. And then that has the same downsides as you're trying to avoid by doing this in the first place. Right?
Anyway, so I guess we don't have experience with these types yet, so I can't speak to basically the advantages you get from never storing to the field, right? I can't speak to whether those outweigh what you would get by stack allocating these things contiguously in these cases where you can't tell what type your variable ends up being because of a merge. And however, I would say that this thing where we don't store is sort of coherent with the way in which we expect and hope to get performance from this feature, and this other one is not. Like, you know, not being able to figure out what the type is and having to, you know, try to alleviate a little bit of GC pressure is sort of not where this value types thing is trying to go. If that, like, there's a coherent.
You don't. You're supposed to say that.
So I can't tell you in advance that I know for sure that
case won't be important. But,
right, but it.
That's not where it's going.
Sorry, can I just interject here for a sec? So, in the interest of time, we've got about 7 minutes left. I'm just wondering if you're going to cover all the things you need to cover in the next 7 minutes, or?
I can try.
Well, okay.
I've been interrupted a lot.
Okay. Because then, like, I only know that we have this room until.
Oh, that was a good question.
And then, yes, it was. But.
Oh, you cover it offline. I'll let you complete it.
Okay, so, no, I mentioned the node flag, so I think that's been in there. I talked about exception point. Operation. Okay, so we allocate as though it's a new. And a bit further down, we'll see that we allocate by actually using new. We initialize each field with the corresponding child value, and that's what it does. So I hope it's a relatively straightforward concept at this point. If we have a weak memory model, we need memory fences to make sure that we don't allocate and then initialize and then publish the thing, and then another thread can see it and see the uninitialized fields. Okay, it results in the reference to the object. It can throw an exception, blah, blah. So, how will it be handled by the optimizer? It's sort of expected to aid in the ways that I've described for optimization. If you're using it, it's pretty likely that you're going to see loads of fields and you're going to be able to do something with them. In terms of all the backends will not need to concern themselves with this because we're going to do lowering, and it does not require any specific machine instructions or anything like that.
Sorry, lower it to what?
So that is just a bit further down in the issue here. Okay. So, in order to do transformations, or in order to generate code for this at all, we have to know what are the fields. And what are the fields is a project-specific thing. We have to ask a question of the project to say, tell me about the fields of this thing. And for each one, we need to know at least the offset and the data type, and then we can recognize corresponding loads, right? We can also, if we know this information, we can generate the stores that we have to actually do at runtime to affect the initialization, right? So, of course, I say there are no stores, and that's true in the form of the IL that is using new value. And you can do all the optimizations. In order to implement this, of course, we're going to have to store to memory. So we have to know where to store, and we can ask the project about that. Okay, now, in order so that we don't have to implement this on every backend, we can do a lowering pass. And there's an example here of what one of these would look like, although now I think we're going to have to do the load adder to specify the type so that we can get the GC point aliasing. It would turn into the sequence where we anchor each child so that those are evaluated first. We do a new where we can skip zero initialization. and then we store each value into the next thing. And then finally, if a memory fence is required, that would be at the end of that sequence. Hopefully we wouldn't have to generate all this anchoring all the time, but in general, we may need anchoring to prevent internal pointers from being commented across the new. So because of this, so there's none of the children should be internal pointers themselves, but they may be computed based on an internal pointer that was evaluated above. And if that were the case and we evaluated these below the new, then the internal pointer is now commented across the new. So in that case, we would have to anchor. Now, we could detect that case and only anchor the ones where it's necessary. Because this also, it forces all the registers for all these things to be live at once, which we don't necessarily want to do, right? If we could separate them out, as long as there's no internal pointer that is going to get evaluated and be commented across here, we can put the child just under the corresponding store. And then we'll need to be able to make up field shadows for these stores so that we can actually generate them. But we'll want to do that based on the type information that we've gotten from the project-specific query to say, tell me the type information. So we say, it'll tell us that there's X at +8 or something. And then given that we have X at +8, which is a float, give me a symbol reference for this. That should also be a project-specific extension point, because there are going to be natural occurrences of, say, vec3.x, and we'll want them to use the same symbol reference. And currently, those natural occurrences are generated in a project-specific place. So if we want to enable using the same sim ref for those things, we'll have to ask the project to do it. So I guess those are most of the things. There's something here about testing and validation. So I hoped that we could talk about validation here. The testing is a bit awkward, considering that my impression is that at present we can't run new in OMR without any more specific project specialization. But if we could mock the new and mock up the type definition and type introspection, then we could test it that way. And that's, there it is. It's now the end of the meeting.
Okay. Any other questions on this? I mean, there's a lot to go through and to think about here. Maybe we should let it sit for a little bit, and if we have any immediate questions, we can ask in the issue. Are there any fundamental objections to this outright? No.
What's the process for getting an IL approved? Like, is it sort of, do people vote on it, or how? Like, what's the plan for OMR to do this?
I think it's just based on the consensus of the discussion that we have, right? So if we overwhelmingly we think that it shouldn't be an opcode in its own right, then obviously it won't. So. But yeah, there isn't an architecture board or anything like that.
I was curious.
Yeah, it doesn't sound like there's any sort of fundamental objections to this one. So there's a few issues to get a couple of loose ends, right? But okay, cool.
All right, thanks, everybody.
There's something else? Okay, that's the last topic for this week. So we're going to adjourn now. So thanks, everyone, for participating.